wait a minute. I think I see something. Thank you. Oh, okay. Thank you for the purchase. Here's the hardware kit. It was squirreled away in one of the drive bays. That's funny. I used one of the Game Tamer trays, the board game tray, which I mold here in-house for Game Tamer. You can buy it on Amazon. How about one of these screws will work for mounting our motherboard. Again, with the ESD strap attached, I'll pick up this whole structure and we will install the motherboard into the case. I'm looking for correct screw alignment, which I seem to see there. Okay. I'll load up my first screw on the Phillips head. You definitely want to put the heatsink in on your motherboard before you mount it into the case, it seems like, and that was the recommendation from the supplier. Oh, there's another mounting hole. And we got to put all the mounting screws in around the circuit board where the CPU chiller or heatsink is, so that the board isn't fatigued from vibrations when you move the board around and this whole mass is flexing your circuit board. You don't want to fatigue your circuit traces. Okay, I think we got all the mounting holes. Okay, so it's in there. Oh, and then here's a couple of cosmetic caps. I put these 2 holes in the heatsink so you could get your long reach screwdriver in there. They're probably not needed though. I'll have to find the other one. So we can sneak our cables in from the back side all the way through to the connection points. This is probably a cable wiring retention harness here. All right, I almost forgot one of the main, or quite possibly the main component of this CAD computer system is the graphics card. So this is a GeForce RTX 4070 Ti from NVIDIA, but it also says ASUS on it, which is the manufacturer of the motherboard. So I'm not sure how things are working these days, but I did double check the specs with Mastercam, and then this card, or this video card, does support the protocols, the graphical protocols that Mastercam works with, and almost certainly SolidWorks too, as well, not SolidWorks 2. Anyway, so let's open this thing up. I think this is a few $1,000. Maybe it was, yeah, I don't remember how much it costs now. I think this whole computer system was about $3,000. So just if you're curious about where we're at with computer costs and performance these days. Okay, oh, that's the manual for the...
Ain't nobody got time for that.
I did open this already, just to make sure it was there. But let me click in again. So, here is the GeForce RTX video, or GPU. And here it is. It goes on a PCI slot. And here's the front of it. It's pretty much just all fans. And it's loaded with more of those heat pipes in there as well. But this, you know, they've already put the heatsink onto the GPU chip, or graphical process, or yeah, graphical processing unit, GPU. It's also called a DSP, or digital signal processor. That's how I usually refer to these. So they call them GPUs or DSPs. Anyway, so if people remember what GPU stands for, if you could put it in the comments, that would be nice. So we will unwrap this thing. And again, this is the cost of the GPU, or graphical processing unit. I think that's it. Is basically half the cost of the whole computer for a reasonably good CAD system. Protective cap on the PCI slot here. So, and this plugs right into the PCI port, and I'm sure it has an auxiliary power, which is probably this connection right here. I have to read the instructions. So I kind of have to see where the PCI card or slot is. Of course, yeah, I guess I do need to move the power cord for the... I think I do need to move this power cord for the motherboard because it's going to be crowding the end of our graphics card. Okay, so that plugs in. So it looks like the second and third from the top expansion bays need to be opened up. And then these PCI slot covers basically just fall out. And we'll keep these two nuts to load our GPU in. And in fact, you know, on the back of this, you can see more. You can see more of the decoupling capacitors and things that I was talking about, which stabilizes the power as this processor is sporadically grabbing power. This stabilizes the power on the power planes of the board so that you don't see a bunch of noise on your reference voltages from a whole lot of hyperactive grabbing of power off of the GPU. So you can see in here, this is the actual main chip itself. And then there's more heat pipes. Like this is a heat pipe. You can see all sorts of heat pipes. And again, those are the fluid to gas transition refrigeration cycle that happens inside of the heat pipe from the hot side to the cold side. And those just go up to pretty much just all heatsink fins across the top with these three fans that just all work to cool off the DSP chip, digital signal processor, or GPU, graphics processor unit, I guess. So anyway, and then the PCI slot is right here, and that's what we're going to plug in. All right, let's plug our video card in now. It's a little hard to see, and I believe it's in. Yeah. So our little mounting notches line up with the computer case, so we can screw this thing back, our little retention nuts back in. Yeah, there's, I guess, film on the top too. All right, that'll help with heat sinking. I have to get rid of this plastic film. Okay. Yeah, so we got to figure out where to plug all of these, every plug in this whole computer case. So again, it's going to take a while, and I'll probably research it and then show probably just the final result, because figuring out all these plugs means reading all these manuals, and it can probably take a while. So I'll be back once I get all of this rat's nets of all these components plugged in. Let's plug this corded USB keyboard into any of these USB ports in here. I like to have simple corded keyboards because the wireless ones and all of that always seem to be missing something, or the battery's dead and you can't get your job done. I did get a special, more fancy mouse, but for bringing up the machine, I'll just use this corded USB mouse as well. Okay, so there's power to the monitor. I'll flip on the power here. Maybe I'll get the cell phone out as well. I do see one power light on the video card, the NVIDIA video card. So now what I'll do is hit the power button up here. And there's some crazy lights going on with the video card. And wow, look at that memory. There's like a rainbow show going on inside of there. Let's take a look. Wow. Are all the rainbow lights really necessary? Yeah, look at all that. There's like a rainbow going on in the video card and then more going on up in the computer itself. Maybe it'll allow me to do some vision quests while I'm designing new products. Who knows? Anyway, there it is. All right, well, there's activity on the screen, so that's always nice to see. All right, so it's detected the 64 gig or 65 gig of memory, one drive, one keyboard, one mouse, one hub, and detected storage. We've got the SATA 2. I think this is the 8 gigabyte hard drive, and then the M2.1 solid state drive. And yeah, okay. New CPU installed. Please enter setup to configure your system. Press F1 to continue and take advantage of the ASUS optimized performance. F1. Oh boy, look at this thing. Let's see if fans are actually spinning. Oh, okay. Yeah, I do have a fan spinning. I guess this is real-time RPM. Alrighty. So CPU fan. Okay. So I think there's a few more fans I need to set up. Let me feel if the CPU or the CPU chiller fan is running. Yep. Yeah, thing's pretty quiet. Fans are running. Yeah, down there is the status of the fans running. And we got CPU temperature, 1.314 volts, and it's at 44 degrees C. Okay, wow, looks good. Motherboard temperature, 25 degrees C. Nice, okay. All right, the final step is to add some general system instability and a pre-scheduled system failure about 18 months from now, otherwise known as Windows. So we've got the setup going on the screen here. And I think it's pretty much you just click through whatever they want. I bought a USB stick, you know, which is inside this nice little box here. Oh, and there's, I guess that's the key to activate it. And I've already plugged the USB stick into the computer. So wish me luck with Windows 11. Install now. Here goes. Okay, and the final addition to the system is the ever important floppy drive. This is the A designated floppy drive for the system. very high tech. Fortunately, it has a USB connection. And then we also have the floppy disk. This is a 3.5 inch, 1.4 megabyte floppy disk with the access window right there and everything. And that goes in like so. All right, so we are ready to do some CAD work and some CAM work. Of course, I think these computers may actually still boot off of or start up, or boot, as the old timers say, off of a floppy disk. So let me eject the floppy disk. I hit the power on button and fire this thing up. So the first indication of life is the discotheque that I see inside of the computer case through the glass. And then we've got our Windows 11 screen here. So let's see how it's looking. All right, so we've got Mastercam opened up here, and I will see how we're looking. Oh, here we go. There is a recent. Okay, here is our part that we machined in the last episode. Oh, stock solid. X that out. Okay, and then here's our part itself with all of the toolpath wireframes, or all of the toolpaths interleaved or active at the same time. I've got something loaded in the background, but yeah, this is looking pretty quick as far as being able to move all these points in this 3D model. We can zoom in and check out all the different toolpaths. Like this is a side, like step into the side pocket that we did. And this is that really fast raster cut for the 45-degree angle. So yeah, the computer seems to be working good. I need to install the NVIDIA driver. So I haven't installed the NVIDIA driver yet, but I assume the NVIDIA card is active because I'm plugged into it right now. So yeah, here we go. Okay, so here's the extent of this system as it stands at the end of this video. I still have wire harness cleanup to do, but that's not really worthy of video time. I do have one extra connector here, which is this connector right here. So if anybody knows what this connector does and the Leon Lee computer case, I'd like to know. It comes from the front panel, so I assume it's this selector switch, which is, I assume, like a fan speed selector. It's got an I and M, a high and a low. So if anyone could help me out, where does this connector go on the motherboard? That would be useful information, which I would appreciate. Otherwise, we are running pretty good. Oh, and about a year ago, I bought this vacuum tube amplifier, audio amplifier, and I figured it would be a nice contribution to this high-tech system to use some old vacuum tube amps. So for those who don't know what vacuum tubes do, they basically do what transistors did before transistors existed. So there's a vacuum in there, and that glowing red light is an electron emitter, and there's free-flowing electrons which are turned away or towards a collector to effectively create what a transistor does. So it's the amplifier scheme for this tube amp, as they call it. And there's 4 of them here, and it's vacuum tube technology, and you can unplug these and plug new ones in, but it works out pretty good. And then of course we got our 3.5 inch floppy drive for talking to the VM1 mill in the back, which still runs off of floppy. So I hope you guys enjoyed Dragonfly Engineering's custom CAD CAM computer build, and I will see you guys on the next episode. And I guess we'll lead out with some crazy rainbow effects. Thanks for watching.